I'm going to be going over how to perform a Kruskal-Wallis test analysis of variance by ranks for my Business 231 class for spring 2020. Today we're going to go over a Kruskal-Wallis test. To be able to use this test, there's a few requirements that must be met. We use this test when there are several independent populations. The data must be ordinal, integral, or ratio scale. We use the chi-square distribution. There needs to be at least 5 observations in each of the samples, and we rank the data as one group from high to low. This test is also a really good alternative to the one-way ANOVA. And we have our equation that we're going to use in our following example, and that is how we find our H value. We're going to start an example of a Kruskal-Wallis test, which is an analysis of variance by ranks. So let's read our question to start. A professor wanted to know if her first year, fourth year, and graduate students watch the same amount of Netflix each day. She took a random sample from each class, which is displayed in the table to the left, using a 5% significance level to determine if there is a difference between the 3 classes in the amount of hours spent per day watching Netflix. First, we need to set up the null and the alternative hypothesis. So the null, that is going to be there is no difference in the number of hours spent watching Netflix between the 3, and the alternative is just the opposite of that, that there is a difference between the 3 samples. Next, we get the significance level, which is right in the question, so we know that it is going to be 5%. And while we're at it, we will do the degree of freedom, which we know is k minus 1. And that k, there is 3 separate samples, so 3 minus 1. And that is 2, so that is our degree of freedom. We need to figure out our critical value, and as we know, the Kruskal-Wallis test uses the chi-square distribution, so we are going to find out our critical value using the Excel command for that. So we have the chi-square inverse. We know our probability is going to be 0.95. This is a one-tailed test, and we have the alpha as 5%, so that's where we get that 0.95. Our degree of freedom we figured out earlier, which is 2, close bracket, and there is our critical value. So now that we have our critical value, we can make our decision rule for whether or not we are going to reject the null hypothesis. So for this test, the Kruskal-Wallis test, it uses an H value. So our rule is going to be if the calculated test at H is greater than the chi-square critical value of 5.99, we will reject the null hypothesis. So I'm going to just type that out, and then we will move on to calculating our numbers over here for the equation. So now the first step in our equation we need to figure out is the sums of all the ranks. So when we rank these, we're going to rank them as if they were one sample. You'll see what I mean by that when I show you the Excel function. So we're going to start with our first years here. We use the Excel function rank average. We select our first number. We need our reference area, which is the entire group here. We want them in ascending order. And we want to make sure that our reference area is not going to move when we pull down the formula. So we're going to go F4, get the dollar signs, F4, and we'll get them again. We will pull this down, and we repeat for the fourth years and the graduates. So now we're just going to sum up each of the ranks separately. So we've got the first year's sum, fourth year, and we've got the graduate students. So moving on, we start this, so we've got 12 divided by n, which is 30. We get 30 from each of these. If you count those up, there's 30 different points there, and we times that by n plus 1, which we know is 31. So there we go. Next, we are going to take sum of our 1, power of 2, divided by n1. So n1 is going to be the count this guy to this guy. That leaves no room for error for counting, so we're just going to repeat through for the 4th years and the graduates now. Okay. So we just need to find this final part of the equation, and then we're going to put it all together and get our h value. So this is a simple one. It's just 3 times n plus 1, which as we know is going to be 31. Okay, so I'm just going to pause this and I'm going to place in a picture of what our formula should be if it was all put together so we know how to get h. Now I've got a little picture here of what this should look like if we were to put it all together as 1. So we are just going to fill it in here. So we have part 1, which is going to be times the sum of these 3 and we are just going to subtract this guy. And there we go, we've got our h value. So now that we have our h value there, we can compare that to our decision rule that we previously had made and come to a decision if we are going to reject the null hypothesis or not. So looking at this, our decision rule had been if the test stat h is greater than 5.99, we're going to reject the null hypothesis. So 5.65 rounded is less than the critical value of 5.99. So we fail to reject the null hypothesis. So step 5, we need to write our conclusion. So because we failed to reject the null hypothesis, that means we are in favor of the null, which was there's no difference in the number of hours spent watching Netflix between the 3. So in other words, there probably is no difference in the distribution of 1st years, 4th years, and graduate students and how many hours they spend a day watching Netflix. So we'll write that in here. And we're all done.